Bismillahirrahmanirrahim. Dear students, Assalamu alaikum. Today we are going to start numericals 10.4, 10.5, and then 10.6. These numericals are on page number 18 of your 10th class textbook. The first numerical, that is 10.4. I read the numerical for you first. A simple pendulum completes one vibration in 2 seconds. Calculates its length when g is equal to 10 meter per second square. This is the statement of the numerical. So we solve the numerical now. Given data, time period is denoted with capital T and it is 2 seconds. Then acceleration due to gravity, value of acceleration due to gravity is g, which is 10 meter per second square. This is the understood value. We have done so many times. To find length of the simple pendulum L, in this numerical we are asked to find length. So we will use the same formula. In solution time period, we use this formula T is equal to 2 pi under root L over G. We use this formula in 10.1, 10.2 and 10.3 numerical. We will use in this numerical also this formula. What I'm going to do, I'm going to yes, I'm going to take the square on both sides. T square equals to 2 square is 4 and pi square, and this square will be cancelled out with square root. So L over G will be left. Then what will we do? Uh, we will take cross multiply on both sides. So length will be separate out. So putting the values, value of T is 2 and value of G is 10 meter per, value of G is 10 meter per second square. Value of G is 10 and then 4 and value of pi is 3.14 whole square. So 2 square is 4. This 4 will be cancelled with the bottom 4. So what is left? So this here will be the square, right? 10 divided by 3.14 square. There is a mistake over here. So you need to put this square over here. So 3.14 whole square, take the 3.14 whole square and then divide this by 10. You will get 1.02 meter. So length, unit of length is 1.02 meter, which is the required length. I repeat the numerical for you. A simple pendulum completes one vibration in 2 seconds. Calculate its length when g is equal to 10 meter per second square. So numerical is 10.4. I write the given data. Time period is equal to 2 seconds. Then acceleration due to gravity, value of acceleration due to gravity is 10 meter per second square. The unit of acceleration due to gravity is meter per second square. In this numerical, we are asked to find length of the simple pendulum. Length of the simple pendulum is denoted with the letter small n. So solution, if we go back to the solution, time period is equal to 2 pi under root L over G. We use this formula in 10 numerical 10.1, 10.2 and 10.3. Taking square on both sides. So here T square equals to 2 pi L over G square root whole square. So this, if I open this bracket, so 2 square will be 4 and pi square and this square root will be cancelled with square, this square. So what is left? T square is equal to 4 pi square L over G. So I am, by cross multiplication, I am going to separate L out. From this formula, I am going to separate L because I want to find out L, length of the simple pendulum. So just put the value T is given to me, which is 2 seconds. I am just putting the values in this formula. In this formula, I am going to put this value. 2 whole square, value of G is 10, 4, and value of pi is 3.14, which is the understood value of pi. 3.14 whole square. If you 2 square is 4, this 4 will be cancelled with this 4. What is left? 10 divided by 3.14 whole square. Student, square will become here because there is a mistake over here, a little bit mistake here. So if you solve this with the help of calculator, you will find L equals to 1.02 meter. The unit of length is meter. So now I'm moving towards numerical 10.5. Numerical 10.5 is also on page number 18. I read the numerical. If 100 waves pass through a point of a pendulum in 20 seconds, what is the frequency and time period of the wave? If wavelength is 6 centimeter, calculate the wave speed. So I'm going to write the given data. Number of waves, since this is the number of waves is denoted with small n, which is equal to 100. It is given to if 100 waves. So number of waves, how many number of waves are there? N equals to 100. So wavelength is denoted with the letter lambda equals to 6 centimeters. This is also given to me 6 centimeters. So what I am going to do, I am going to convert this 6 because the unit of lambda is the length. The unit as a unit of length is meter. So I need to convert this into meter. So what will I do? I will divide this with 100. 6 divided by 100 because centi is equal to 10 raised to the power minus 2 and 10 raised to the power minus 2 when divided. So 6 divided by 100 is going to be 0.06 meter. What else is given to me? Time taken is denoted with a small t, which is equal to 20 seconds. This is also given to me. This is given to me 20 seconds. This is 20 seconds. So to find what I need to find in this numerical, calculate the wave speed. And so in order to find the wave speed, first of all, I will write frequency I need to find out. Then time period I need to find out, because what is the frequency and time period? In this numerical, three things are required. What is the wave? What is the frequency? First thing is frequency, and the next thing is time period. Time period is denoted with a capital T, and the last thing which we need to find out, calculate the wave speed, and wave speed is denoted with the letter small p. These three things are required in this numerical. I will use the formula frequency. Frequency is denoted with a small f equals to number of waves passed divided by time. So number of waves is denoted with small n and time is small t. So I am just putting the values. Number of wave speed and fast is equal to 100. How many waves are there? 100. So 100 and time is also given to me, which is 20 seconds. If I divide this 100 divided by 20 equals to frequency. Frequency is equal to 5 hertz. So unit of frequency is hertz. So this is one thing I have found. Frequency f equals to 5 hertz. Next, this is the continuation. 10 point. So we have done this one. So this is the continuation of the same numerical 10.5. So in last slide we found frequency which was 5. So time period, the formula for time period is 1 hour f. When we read the book, we found the formula time period is equal to 1 hour f. So I will put the values frequency. Frequency is equal to 5, which we just found. So 1 over 5 equals to 0.2 second. The unit of time period is second. So 0.2 second. Time period is equal to 0.2 seconds. Now I will find the third thing which is required in the numerical. The formula to find the speed v equals to f lambda. So value of frequency we found just in the last slide. 5 and lambda value is 0.06. If you multiply this, so you will get v equals to 0.3 meter per second. This is the end of the numerical 10.5. So students, we just did 10.4 numerical and 10.5 numerical. Now I am moving towards numerical 10.6. Numerical 10.6 is, I read the numerical for you. A wooden bar vibrating into the water surface in a ripple tank has a frequency of 12 Hz. The resulting wave has a wavelength of 3 centimeters. What is the speed of the wave? There is a wooden bar vibrating into the water surface in a ripple tank has a frequency of 12 Hz. The resulting wave has a wavelength of 3 centimeters. What is the speed of the wave? In this numerical, we are asked to find speed of the wave. So, frequency is denoted with a small letter, small f, which is 12 hertz. The unit of frequency is hertz, and the wavelength, which is given to me, this is frequency is given to me, and the wavelength is given to me 3 centimeters. So again, we need to convert the wavelength into meter because the unit of wavelength is meter. This is the smaller unit of the length. So we, in order to convert this SI, we divide this by 100. So 3 divided by 100 is equal to 0.03 meter. So we have converted this length centimeter into meter length. So the same numerical 10.6 which is continued. In this numerical, we are asked to find speed of wave. Speed of wave is denoted with letter V. V equals to V we need to find out. Solution V is equal to F lambda. Lambda is a wavelength. Frequency is F. So if I just put the values, F is equal to 12 or lambda is equal to 0.03. If you multiply 12 multiplied by 0.03, you will get 0.36 meter per second. V equals to 0.36 meter per second square. This is the end of the numerical 10.6. So, students, I hope you understand. I just repeat I did only 3 numericals. I can do more numericals, but for your ease, because you want to do by yourself, couple of times you need to revise this or repeat this. That's why I take only 3 numericals. So, just at your home, do practice as much as you can. I repeat the numerical you for it again. Your homework is practice your numerical 3 times on your rough register and then transfer them on a neat register. So I am going to repeat the numerical what we did today. We class 10 physics subject physics. Topic of today's lecture was 10.4, numerical 10.4, 10.5 and 10.6. Pages, these numericals are on 80. So we did the first numerical. This one, which was 10.4. I'm going to repeat the whole numerical, 3 numericals for you again. A simple pendulum completes one vibration in 2 seconds. Calculate its length when G equals to 10 meter per second square. So first numerical, that's 10.4 numerical. Sorry. 10.4 numerical is a simple pendulum completes one vibration in 2 seconds. Calculates its length when G equals to 10 meter per second square. This is the statement of the numerical 10.4. Now, according to the statement, I am going to write the given data. Time period is denoted with a capital T, which is given to me 2 seconds. Here it is mentioned 2 seconds. So acceleration due to gravity, the value of acceleration due to gravity on the surface of Earth is 10 meter per second square, which is understood. So it is also given to me. Now, in this numerical, I want to find out to find length of a simple pendulum. Length of the simple pendulum is denoted with a small n. I will use the formula T is equal to 2 pi under root L over G, or you can say square root L over G. Because I want to separate out L, so that's why I'm taking the square on both sides. Why I'm taking the square on both sides? In order to cancel out the square root. So T square is equal to 2 pi under root L over G whole square. So 2 square will be 4, 5 square, and then square root will be cancelled with this square. So T square is equal to 4 pi square L over G. I am going to separate this out L. So by taking cross multiplying on both sides and just putting the values. The value of T is equal to 2 and G is 10 and 4 and value of pi is 3.14 whole square. If you take the 2 square, it will be 4. This 4 will be cancelled with this 4. So here square will come. I have already given told you that is the small mistakes over here. So 10 divided by 3.14 whole square. If you divide this, you will get 1.02 meter. The unit of length is meter. Now, the next numerical is 10.5. 10.5. 10.5. If 100 waves pass through a point of a medium 20 seconds, what is the frequency and time period of the wave? If wavelength is 6 centimeter, calculate the wave speed. 100 waves is mean number of waves. Number of waves is denoted with the small letter n, which is equal to 100. It has no unit. Wavelength is lambda. Since it is a length, so its unit will be meter. So what we have to do, I was given 6 centimeter. This was the smaller unit of the length. I need to convert this into meter by dividing by this with 100. So 6 divided by 100 is 0.06 meter. So time is given to me this time period. Time period is the difference between time period and time. So if there is a time period, then we will use the capital T. But if it is the time only, then small t will be used. So t will be time taken. T is equal to 20 seconds. To find in this numerical, we ask to find frequency, time period, capital T, and speed of the wave, which is v. So frequency is formula for frequency is number of waves passed divided by time, n divided by small n divided by t. So n is 100 and time is n is 100, n is 100 and time is 20. So if I cancel this out, so 5 hertz. The unit of frequency will be 5 hertz. Next, we are required to find time period. So I will use the formula time period is equal to 1 hour n. So time period and frequency are reciprocal to each other. This is another formula to find the time period. Time period is equal to 1 hour n. We have read this formula already. So 1 divided by 5, we just put the values 5 and value of frequency which is 5 and 1 over 5 is equal to 0.2 seconds. The unit of time period is second. So I found time period 0.2 seconds. Next, we need to find out speed of the wave. We will use the formula V is equal to F lambda. So frequency we just found in the last slide 5 and lambda is 0.06 which is given to me. If I multiply this 5 multiplied by 0.06, we will get speed of the wave 0.3 meter per second. The unit of speed is meter per second. This is my end of the numerical 10.5. Now I start numerical 10.6. I read the numerical statement. The wooden bar vibrating into the water surface in a ripple tank has a frequency of 12 Hz. The resulting wave has a wavelength of 3 centimeters. What is the speed of the wave? In this numerical, what is given to me? Frequency is 12 Hz because Hertz is the unit of frequency. So frequency is not to be the small letter M. The 12 Hz wavelength is given to be lambda, and lambda is 3 centimeters. Again, this is the smaller unit of the length. So centimeter is the smaller unit. So I convert this into the SI unit, which is meter. So 3 divided by 100 is 0.03 meter. So I converted this. Next, this is a continuation of same numerical 10.6. Speed of the waves. Here we are asked to find out speed of the wave, and speed of the wave is denoted with the letter small v. So solution v is equal to f lambda. I just put the values frequency. F is 12 and lambda is 0.03. If we multiply this 12 multiplied by 0.03, we will get speed 0.36 meter per second. Meter per second is the unit of speed. So V is equal to 0.36 meter per second. I hope you guys understand it very well. If you have any question regarding these three numericals, please let me know.